Hi everyone. Today we are going to discuss 2022 May June paper 5 unit 5 this paper. First of all, we'll go through MCQ questions. Now first they had given some E cell values and they asked which one of these ions most likely to catalyze the reaction between this S2O8 and I minus. Do you remember this one is there in the textbook as it is, children? So when S2O8 ions actually react, first of all Fe2 plus ions are involved, right? Because this S2O8, if you need to find the oxidation number, you can find it. So you can get this thing as X, 2x plus 8 into minus 2 equals minus 2. So here it is minus 16, put it to the other side, then you are getting 14. So you are getting oxidation number as plus 7. Then SO4 2 minus means x plus 4 into minus 2 equals minus 2. Then you are getting plus 6. Plus 7 changes into plus 6 means it should be reduced. So something should give electrons for that. So that's why Fe2 plus at the same time changes into Fe3 plus. Thereafter in the second step, this I minus convert into I2. In that case, this Fe3 plus reduced to Fe2 plus. That's what happens, right? So here you have to by heart these two equations because once they have asked to write the equations as well, right? So answer would be Fe2 plus. So here it is straight away answer, right? Okay. Then when it comes to types of catalysts, so we can mainly divide types of catalysts into homogeneous and heterogeneous. Homogeneous means they are having the same phase as the reactants. Now say for example, if you think about the enzymes, or else do you remember that SO2 conversion of SO2 to SO3? There what does it involve, children? NO2 is involved, right? So in the second step, this NO reacts with oxygen to regenerate NO2. That's why we called it as a catalyst, right? Okay, so that's one example of homogeneous, right? So heterogeneous catalysts, they are having different phase, like iron catalyst in Haber process, then vanadium V2O5 in contact process. Those are the catalysts we can use, right? So keep it in mind, right? Keep it in mind. So here it is, all of them are in aqueous medium. So Fe3 plus and Fe2 plus, even they are in aqueous medium. So we can accept as what? Homogeneous catalyst, right? Okay. Next one, which substance is manufactured in the process involving reaction V2O5 catalyst? As I said before, V2O5 is used in contact process, that is making H2SO4. Other one is iron catalyst is used in what? Haber process. Some common examples, right? Okay. So here V2O5 is making sulfuric acid, right? Now in this fuel cell normally they ask you have to by heart both the equations in acidic condition, in an alkali condition. Both of them are in the textbook, please refer them, right? So in acidic condition, the difference is now hydrogen actually it oxidizes to forming H plus ions, and positive electrode, it's something like this, oxygen. So anyway, if you take the overall reaction, both the cases overall reaction means H2 plus O2 gives water, right? So in alkaline condition, H2 and OH gives water first, and after that this one OH regenerate. These two equations are very, very important, right? So in that case you all have to know, right? So when it comes to acidic condition and alkali condition, we have already OH minus ions. So we normally do it in alkali condition, so that is much more efficient because OH minus ions can be used as a catalyst, right? Okay. And some advantages and disadvantages of fuel cell. So if you think about the advantages, means there is no pollution because water is only the product, right? So it's environmental, eco-friendly, right? Disadvantage, actually hydrogen is stored under high pressure, right? So it may be explosive then, right? That's one of the disadvantage, right? Now here negative electrode they are, so this is the equation. Straight away you have to but here alkaline negative, alkaline negative means this one. So you have to get hydrogen in OH medium, H2 and 2 electrons. So answer is A. And the other one they ask, compared to acidic condition, what is the importance of this alkaline thing? So catalyst, OH minus already there, children. So alkaline fuel cell is much more efficient, right? Okay. Please remember the equations given in the textbook, right? Next one. Excess aqueous sodium thiosulfate is added. Sodium thiosulfate formula is H2O3, 2 minus, right? And added to vanadium, that ammonium vanadate means, children, VO3, 2 minus. But even though if you don't know this formula, but it says that vanadium oxidation number is plus 5, right? Okay, got it. Now in that case you have to know, children, maximum oxidation number of vanadium is plus 5. So definitely this one go to the lower oxidation number, that is plus 4, right? Plus 3, plus 2, like that. So it can goes until up to plus 2. Do you remember these colors, right? So this one actually VO3 minus, or else sometimes we can say that one, children, VO2 plus, right? VO2 plus, even having plus 5 oxidation number, right? So look at VO2 plus, that's plus 5 oxidation number, that's yellow color. And VO2 plus, that's plus 4 oxidation state, that's blue color. Then V3 plus 3 oxidation number, that's green color. And plus 2 finally, that is pink color. Now we have to think whether it changes into blue color or else green or violet. That's why they ask us to refer the data booklet. Now if I refer the data booklet, children, in data booklet you can find all the oxidation numbers. This is page 10 of the data booklet, right? Now there are some equations, right? Look at S4O6 is there, that's plus 0.09, right? So I'll take some of these oxidation numbers, then it's easy for you, right? I'll take this H2O31, VO2, V3 plus. I need V3 plus as well. Then we have to say that it does not convert into these ones are needed, right? So I'll take them here. I'll get it to this thing, right? Now if I take all of these I'll put these E cell values even, then it's easy for me, right? Is the color, these are the E cell values, right? Okay, now look at this. Now the thing is this, children, now you can see that H2O3 appears there in the right hand side of the equation. That means definitely H2O3 must be oxidized, because other fellow should be reduced. Now look at this oxidation number, E cell value is plus 0.09. Normally reduction potential would be more positive one, and oxidation would be less positive. Now we'll go through first one. First one was VO2 plus, this one, the last one, that's plus 1. Okay, plus 1 E cell value is bigger than this 0.09, so that reaction is feasible. That means, children, this VO2 plus can convert into VO2 plus, can convert into VO2 plus, because this oxidation number is plus 5, this oxidation number is plus 4, this E cell value is 1 positive, E cell value is plus 1. Okay, that value is more positive than plus 0.09, because that H2O3 E cell value is plus 0.09. Okay, because when the E cell value is more positive, that one tend to reduce. Okay, so this reaction tend to reduce and this one tend to oxidize, right? Thereafter you think about V3 plus VO2 plus, that means plus 4 to plus 3. Look at that E cell value, VO2 plus 15th one, VO2 plus to V3 plus, that's plus 0.34. That's plus 0.34. Even that one also more positive, so that reaction even undergoes, actually that reaction also occurs, right? That means it goes until up to V3 plus, means that's green color. Then you think about 3 plus to 2 plus. 3 plus to 2 plus means, look at the 9th one, that's minus 0.26. This E cell value is minus 0.26, but this one is plus 0.09. So this one cannot be reduced further, because this E cell value is more negative than that H2O3 E cell value. In order to, you know about feasibility of a reaction. Reaction is feasible when the E cell value is positive only. Since this E cell value is negative, children, the reaction will stop at V3 plus. That's why the final color would be green, right? Now in this question you all have to know about colors of each vanadium substance plus the feasibility of a reaction. So vanadium, there are 4 oxidation states, plus 5, plus 4, plus 3, plus 2. Remember the colors, yellow, blue, green and pink. And each step, by looking at the E cell value, check the feasibility, whether this reaction occurs or not. That's all. Right. So final color would be green color, right? Okay. Next one, isomerism of transition elements. Now we all know that transition elements can show stereoisomerism. Under stereoisomerism, we have to think about cisplatin and transplatin. So normally we say, children, cisplatin means when the substance actually act or substance are fixed in the same side, same cis, and whenever they are opposite to each other, that is called transplatin. Now hope you remember about DNA replication, right? So in DNA chain, you know that there are nitrogenous bases, and chlorine can be bind easily, right, compared to other nitrogen bases. Therefore, when chlorine is fixed in the same site, children, we can stop replication by fixing this one. Now in order to do this thing, we have to select the compound with cis and platin, but in there, remember, chlorine should be fixed in the same site. That means it should be the cisplatin one, right? So fourth one, we have to accept the answer C, because chlorine must be fixed in the same site. That should be a cisplatin one. Right. Next one. This reaction is also important, children. You have to know about this dichromate and chromate thing, right? So CrO4 minus, that means dichromate, right? Dichromate 6 convert into dichromate 7, right? So this reversible reaction, remember with the colors, so CrO4 minus is yellow color and Cr2O7 is what, children? Orange color. Now look at, if you put any amount of acid, right, what will happen? This equilibrium shift forward. That means yellow color can be changed into orange color. But if you put any alkali over here, what will happen? This H plus tend to react with the alkali. So as a result, what happens, children? It favors the backward reaction. So orange color changes into yellow. Now they are asking which one shift in equilibrium result in formation of yellow solution. So it should be the backward reaction. In order to favor the backward reaction, either you have to remove H plus ions, or else you can put some amount of alkali. When you put some amount of alkali, H plus ions are removed from this system. Thereafter what happened? It favors the backward reaction. So whenever you have to add NaOH, NaOH tend to react with H plus, so that is same as removing H plus ions or removing acid from the system, and the equilibrium shift backward, right? So question 5 answer is A, right? Question number 6, percentage uncertainty. Now uncertainty equation is what, children? Uncertainty equals error over reading into 100, okay? Now whenever you use the apparatus, you have to think about how many times the reading is taken. Say for example, if you take a burette, we have to take the reading twice. If you measure the initial and final temperature, that also you have to take the reading twice, right? So if you take initial mass and final mass, that also you have to multiply by 2. But if you take the reading once, say for example pipette, so we don't need to multiply it by 2. Keep it in mind. Now since they have mentioned, now here in the question even it says, children, uncertainty of each burette reading. So obviously we are taking final and initial, children. That's why. So we'll substitute that one. Percentage error is 0.32 equals error we have to multiply by 2. Reading is missing into 100. So take reading over here, children. Take reading there. So 0.05 on 2 over 0.32 multiplied by 100. Right. So that's how we are getting 31.25. So answer is C. Right. Next one, 7th one. Now in that case, children, you all have to count the number of carbon atoms and hydrogens quickly, because they are asking percentage by mass of carbon. So we have to find how many carbon atoms are there, right? Now I'll take first this formula. This is benzene formula, but without 2 hydrogen. So it should be C6H4. This one is having carbon and oxygen, right? And this one again carbon and oxygen. Then here CH2 ne? So I have to take CH2 twice and another oxygen. These are the atoms present in the whole molecule. So this one would be 12 plus 16 plus, here 12 into 6 plus 1 into 4 plus, here again 12 plus 2 oxygen, 16 into 2 plus, here 12 and 2 14, 14 into 2 plus 16, right? Okay, then take how many carbon are there? 1 carbon, 7, 8 and 2 10. So 12 into 10 over this entire mass into 100, right? Okay, just substitute the value, so you get the entire mass, and after that you have to take it as the denominator, right? So answer would be 62.5. There you have to know how to get the formula by looking at the structure, and after that percentage by mass means get whatever the element, divide by entire mass into 100, right? That's all, right? This one carbon 13 NMR. Now you have to know about carbon 13 NMR, so you have to think about the different environments. But remember, if the molecule is symmetrical, so you have to divide into 2 halves. Now you can see that this molecule is having same groups attached, right? COOH group, COOH group. That means I can fold this molecule into 2 halves. Look at, this is the line of symmetry. So that means all of these carbon environments are what? Same. If you fold it, it will be overlapped, right? These two even same. So all of them we have to take it as what, children? One environment. So here one environment. This is the second carbon atom, and this is the third environment. So same thing is repeated to the other side as well. So if the molecule is symmetry, you have to draw the line of symmetry and think of it, right? So answer would be what? 3 environments only, right? Okay. The other one, there are 2 types of polymerization. Do you remember that, children? One is addition polymerization, the other one is condensation polymerization. You have to distinguish this. right? In condensation polymerization, there should be either ester linkage or else amide linkage, right? Okay, and this ester linkage or amide linkage must be involved or must be present in the long chain. Now look at this ester linkage is not involved in the long chain because this is the straight chain polymer. Can you understand? So that means that ester linkage is there, but it's actually something outside of the chain, right? But this is there in the straight chain. Now in the straight chain, what we can find, children? We can find only 2 carbon atoms. So 2 carbon atoms means basically what sort of polymerization is this, children? This is called what? Addition polymerization. Because in addition polymerization, what happened? The double bond is broken and other 2 bonds are actually, or 2 molecules are continuously added, 2 atoms, right? So this should be obviously an addition polymerization, right? And so it should be only single type of monomer. When addition polymers are made, basically we can tell that, yeah, single type of monomer, right? So single type of monomer and addition polymerization, answer is C. Oh, my bad. Wait. Answer would be A, right? Single type of monomer. No, different types, single type of monomer. Right. Next one, making diazonium salt. So you know that if you take phenol, we can go back to the reaction until up to phenol. Do you remember? First, this benzene we can convert into what? Nitrobenzene by using conc H2SO4 and conc HNO3. Temperature would be 55. That's nitration. Then nitration we can convert into phenylamine, right? Aniline. So that means we have to use reducing agent. What are those, children? Do you remember that? Tin and conc HCl. Then this one we can either convert into diazonium salt or else phenol. Depends on the temperature. But both the cases we have to use what? NaNO2 and HCl. When NaNO2 reacts with HCl, children, it forms HNO2, nitrous acid. It is made in situ, inside the reaction vessel, right? If you maintain the room temperature, you will be getting phenol. But if you maintain the temperature 0 to 5 by putting ice crystals, so you can get diazonium salt. So in diazonium salt, nitrogen is bonded to 4. That's why this nitrogen should have slightly positive charge. Not slightly, actually it is positively charged. And the Cl is negatively charged. Remember the nitrogen which is having 4 bonds only. This one only has positive charge. If you warm this diazonium salt, again you can get phenol also, right? So this one would be that nitrogen, first nitrogen should be having the positive charge. This is wrong because this one should be the one and this one is correct. So answer is D, because this nitrogen is having 4 bonds, so it has positive charge, right? Next one, making Grignard reagent, right? So when Grignard reagent is made, so we have to use this sort of MgBr and we have to use dry ether. This is straight away answer. So there which solvent is used in this preparation? That's ether only, right? So ninth one, answer is B, ether. Then we use anti-bumping granules. Why? That is straight away answer, children. Solvent boils smoothly, right? Now look at the Grignard reagent, children. Now whenever we use Grignard reagent, normally what do? We take a halogenoalkane and after that we have to heat with magnesium and ether. So magnesium comes in between, remember. Now whenever you put the charge, look at this arm is carbon. So this one is having delta minus, magnesium is delta plus, therefore carbon gets slightly negative charge. So it is not an electrophile. You may think it's an electrophile. No, it's a nucleophile. It's a nucleophile because it has a partially negative charge, right? Okay, so it should be negative and nucleophile. Right. So answer would be D. Right. Now when you put this Grignard reagent with different compounds, say for example if you put RMgBr with carbon dioxide, it gives carboxylic acid. With methanol only with methanol, it gives primary alcohol. Any other aldehyde with CH3 group or any other alkyl group, it gives secondary alcohol, and with a ketone, it gives tertiary alcohol. This is very, very important. Please remember this. Carbon dioxide means carboxylic acid, then primary alcohol, then secondary alcohol and tertiary alcohol. Right? Now they ask one question here. Now first of all you identify what's the part given here. Look at this part is already there. So you separate that. Okay, this is the fellow. No? What happened if you put Grignard reagent over with this thing? What's the other substance here formed? This one is what sort of alcohol? OH is bonded to 3 alkyl groups. That means definitely this one would be what, children? It's a tertiary alcohol. Tertiary alcohols are made by reacting with ketones. Now you try to separate the ketone part. This one would be the ketone. Look at this. So this group should come from the ketone group. Then how do you draw the ketone? It should be something like this. This one and this, and O should be somewhere here. From there only, no. It is connected to the Grignard. So if you connect this fellow into here, what will happen? For this MgBr, this group will attach, and this sort of group will attach, and this one become what, children? OMgBr. Right? Then once you hydrolyze it, H goes here, OH goes here. That's what happens. Now first of all, by looking at the molecule, you identify what is present there in the molecule. Right? You separate that part. Then after that, look at the rest of the substance. If it's a carboxylic acid, straight away it should be carbon dioxide. If it is primary alcohol, secondary alcohol, tertiary alcohol, you decide what sort of molecule must be used. Since this fellow is a tertiary alcohol, I have to take ketone, so I have to separate the ketone part. Now identify what's ketone. Number it. 1, 2, 3, 4, 5, 6. So hexane 3 on, right? Right. So this one would be hexane 3 on. Right. Tenth one. Hope you remember about enantiomers. We can make amino acids into charge according to the medium given. Now they have dissolved in sodium carbonate solution. Remember, carboxylic acids only tend to react with sodium carbonate solution. So therefore what happened? This group become O minus. Alcohol does not react with carbonate. Huh? So this one should be, other groups must taste the same. So answer would be D. Huh? Right. So this answer, they have ionic bonds. Then phenol is more reactive. Answer is A.